I feel like.
All right, so we are going to expand from quadratics to polynomials of a bunch of different degrees today.
So it's okay. It could be improved.
Right. Yeah, English class. So, a term. Okay, this is actually kind of a tough thing to define. Okay, but we're going to say that a term is any set of numbers and variables being multiplied together. So let's write down some examples here. For example, is 2 a term? Is 2 a term? I'm seeing a lot of no's. Seeing some yeses now. I'm seeing some head rolls.
What do you mean? That was obvious.
So, why is 2 a term or why is it not a term? What if I wrote it like this? What if I wrote it as 2 times x to the 0? X to the 0 is equal to 1, right? So that would be the same thing as just 2. But it's equal, right? This is just equal to 2. So, even though a variable doesn't appear here, this is still a term, okay? Because we can always think about a variable to the 0 power, right? So, a constant is still a term. What about x to the 4th power? Sure. What about 4x squared y to the 3rd? Is that one term? Yes, that is one term. Okay, 4x squared y to the 3rd is a single term because it is a collection of numbers and variables being multiplied together. Okay? How about 7 plus x squared? Is that one term?
Nope.
No. Right? This is not one term. This would be 2 separate terms. Okay? How about 7x squared y cubed c to the 4th a to the 7th b to the 384th power?
That's a lot. That's a little bit excessive.
That's one term, right? Okay, so that's our definition of a term. It's a collection of numbers and variables being multiplied together. Where, that could just be a constant, or that could be something as crazy as this. Okay? That is, each of those are one single term. How do we define the degree of a term? Anybody remember this?
Is that the squared or cubed?
Yeah. So what would be the degree of this? 4. How about the degree of this term? 5, right? So the degree of a term is the sum of all powers in a term. The degree of a term is the sum of all powers in a term. How would I define the leading term in a polynomial? Is it just whatever one shows up first? highest degree, right? And what's the leading coefficient? What's the leading coefficient then? What's the difference between leading coefficient and leading term? Right, the leading coefficient is just the number in front of the leading term, right? So it's the number associated with that. Leading term. And finally, what's the degree of a polynomial? So what if, let's look at something. If I give you, I don't know, x cubed plus x squared plus x plus 1, right? What's the degree of that polynomial?
3.
Right? Sometimes you may be tempted to say the degree is 6, right? You would think, well, I need to add all the powers together. That's not the case. The degree of a polynomial is just the degree of the leading term. Right? The degree of a polynomial is just the degree of the leading term. All right, so let's take a look at a few polynomials.
So the degree of a term is the sum of all the powers of it. So like that, you wouldn't be able to have a sixth power.
So each of these are separate terms.
Right.
So the degree of this term is 3. The degree of this term is 2. The degree of this one's 1. So the leading term is x cubed. Therefore, the degree of this whole polynomial is the degree of the leading term.
But if it was like x cubed y squared, then it would be 5.
Right. Yeah.
Okay.
So just like this first example, okay, we've got negative 10 r cubed x squared. So we only have one term in this polynomial. Right? What's that? So what was our definition of a term? Negative 10 r cubed x squared. That's all one term. So my leading term is this whole thing. Negative 10 r cubed x squared. What's the leading coefficient then? This negative 10, right? The number associated with the leading term. So the next one, we've got 3 minus 5x minus 7x to the fourth. What's the degree of this polynomial? 4, right? What's my leading term? The highest power that shows up is 4. Right? Each of these are separate terms, so we're not going to be adding those powers together. It's only when we're multiplying things together, like here, we were multiplying r cubed and x squared together, that we would add the powers. Okay, so the degree of this one, the highest power that we see, is 4. What would my leading term be? Negative 7x to the fourth, right? Even though that doesn't show up first, leading term is whatever term has the highest degree. And then my leading coefficient, negative 7, right? Number associated with the leading term. How about this? Negative 7x plus 11 plus the square root of 2 times x cubed. So my degree would be 3, right? The highest power that shows up is 3. leading term.
Root 2x to the third.
2x to the third. And my leading coefficient.
Squared.
Square root 2. Okay, so our last one looks a little bit different. Okay, this one is in a factored form. We got x minus 3 cubed times x plus 1. Do I have to multiply this all out to figure out the degree?
Hopefully not.
Hopefully not.
I'm gonna hope that we don't.
So the degree is 3? No. Degree is 3? These are being multiplied together, right? This has an exponent of 1, even though it doesn't show up. If I cube this out, okay, we don't have to know all the other terms that would show up, but the highest power that would come out of that is an x cubed, right? The highest power that would come out of this would be an x to the first. So when I have an x cubed times an x to the first, I would end up with x to the fourth power. Yeah, whenever we multiply terms together, we add the exponents.
And it's just one term, so.
Right, everything's being multiplied here, so it's just one. We can think about that as well. If we multiplied this all out, we would end up with more than one term. But the leading term, the term with the highest power, we would have an x cubed out of here and an x to the first out of here. So when I multiply those together, I would end up with an x to the fourth. What would be the entire leading term? We said it would have a degree of 4. Is there going to be a coefficient in front of it? Or is it just going to be 1? Can I figure that out without multiplying this out? Can I see what the coefficient would be? Okay, what is it? So the coefficient, it would just be 1x to the fourth? Just x to the first power? Okay. So how do you know that the number associated with that would just be 1?
Crossing your fingers.
Because it's imaginary. You just know.
Yeah, Mr. Batch. Get off the case, man.
So, since the coefficients on both of these variables are 1, okay, whenever I start multiplying them out, I will only ever be multiplying an 1x by 1x, right? There's never going to be a coefficient in front of that leading x term. Okay, so that leading term will just be x to the 4th. Okay? What about, well, then I guess that answers the question of the leading coefficient as well, then. Right? The leading term is just x to the 4th, the leading coefficient is 1. Alright? So, we'll be able to see, I think, this one a little bit clearer once we start talking about a little bit more of the properties of polynomials here. Alright, but any questions so far? Alright, so then we just have a little set of terms to name polynomials. Okay, so first by the number of terms, and then by the degree of the leading term. So if we have just one term in a polynomial, it's called a monomial, right? That prefix of mon means 1. We have 2 terms, it's a binomial, right? Bi means 2. We have 3 terms, it's a trinomial. And then anything past that, we just call it a polynomial, right? 4 or more terms. Poly just means many. Then we can classify them by the degree as well. Okay, first degree is linear, second degree is quadratic, third is cubic, fourth is quartic, fifth is quintic, and then after that, we just kind of say 6th degree, 7th degree, 8th degree. Sure.
Can we do something that is quick?
Sure.
Alright.
You want to do something right now that's quick?
I mean, if it's not that hard.
We'll look at some here. Okay, so some common properties of polynomial functions. First of all, the domain is always negative infinity to positive infinity. Okay, the domain of any polynomial function is all real numbers. The graph is smooth and continuous. Okay, I mean, you guys know what polynomials look like. I mean, there could be lots of hills and valleys, but it's all going to be a smooth graph. Okay, there's never going to be any corners or cusps or discontinuities. Right? There will also never be division by a variable. We could never have something like 1 over x, right? That is not a polynomial, right? No division by a variable. And then finally, the variable's exponents can only be whole numbers, right? So even something as simple as x to the 1/2 power, right? The square root of x, the same as x to the 1/2 power. That is not a polynomial because the variable has a fractional exponent. Okay, all exponents can only be whole numbers. So these are our basic properties of polynomial functions. So the next item you guys worked on in Algebra 2 and in pre-calc. Right? End behavior just talks about what the graph does really far to the left or really far to the right. Okay? Polynomials can do a whole bunch of crazy things in the middle. Okay? But end behavior just says, well, what's going on way over here, way over here. Okay, so end behavior describes where f of x. So f of x is the same thing as the y value. And it's saying what happens to the y value as x goes to infinity or negative infinity, right?
So end behavior describes where the y value goes from.
So from left to right, whereas x goes to negative infinity and x goes to positive infinity. Okay, so this is how we're going to write this. Okay, going to the left is just saying as our x value goes to negative infinity. Right? Going to the right is just saying as x goes to positive infinity. So the end behavior is determined by the degree and the sign of the leading coefficients. So there's only 4 possibilities. Okay? If I have an even degree polynomial. Okay, so even degree functions could be x squared, x to the 4th, x to the 6th, right? Any even power of our leading coefficient. The end behaviors will both be going to positive infinity. Okay? I don't know what all is going on in here, right? I don't care what all is going on in here. All I care about is that as we go to negative infinity in the x direction, the y's are going to positive infinity. As I go to positive infinity in the x direction, the y's are going to positive infinity. Okay, so the way that we write that, I don't think there's an extra space. Yeah, so the way that we write that, let's put it down here, yourself some room. We're going to say as x goes to negative infinity, So as we go forever this way, f of x, which means the y value, goes to positive infinity. Right, then as x goes to positive infinity, f of x also goes to positive infinity. Okay, so when we're describing end behaviors, we'll have two statements, always. Right? We'll have one statement saying as x goes to negative infinity, f of x goes to whatever, and as x goes to positive infinity, f of x goes to either positive or negative infinity. So for the second one, okay, for an even degree where our leading term is negative. Okay, so here, I'll rewrite these. We said, x squared, x to the fourth, x to the sixth, so on. Here, we're just saying, well, I'm going to take even powers and make the leading coefficient negative. So like negative x squared, negative x to the sixth. So this time, the end behaviors, okay, what's happening on the ends of the graph, they're both going down. So we can say, as x goes to negative infinity, f of x goes to what? Yeah, as x goes to negative infinity, f of x will go to negative infinity. And as x goes to positive infinity, f of x goes to negative infinity. Okay. We're still going down over here. Odd functions, they're odd degree functions. Their end behaviors will go in opposite directions. So here, okay, we're saying our leading coefficient is positive and our leading term has an odd degree. So that could be x to the first, x cubed, x to the fifth, right? Keeps going. So here, we can say our end behaviors be as x goes to negative infinity. What is f of x doing? F of x, the y value is going to negative infinity. And as x goes to positive infinity, what's the y value doing? Positive infinity. And our last one, okay, an odd degree, where the leading coefficient is negative, so like negative x cubed, negative x to the fifth. Okay, it's just reversed what our positive odd degree would do. So as x goes to negative infinity, our y value goes to positive infinity, and as x goes to positive infinity, f of x goes to negative infinity. Okay. Question? All right, so let's try a couple then. Okay, let's jump down here to example 1. Negative 2x to the third, right? That whole thing is my leading term. So what I'm looking at to determine end behavior are the degree and the sign. So this is a third degree. That means it's odd, or an odd degree, right? And it's negative. So as x goes to negative infinity, what does f of x do? We got a negative odd degree. We go to positive infinity. And as x goes to positive infinity, f of x goes to negative infinity. For me, personally, I like to sketch a rough graph out. Okay, now not saying, you know, we need to find a whole bunch of information. I'm just saying, well, if I know that this is a negative third degree, okay, well, if we base this on our parent function, right, x cubed does something like that. So if I take the opposite of x cubed, that's going to go the other way, right? Negative x cubed will do something like this. Okay, so I can hopefully visualize the end behaviors, right? Okay, and again, that comes back to knowing what the parent functions are. Okay, if you want to sit there and use your arms, you're more than welcome to do that too. Okay. So you guys try B. Okay, figure out what the end behaviors would look like for B.
Your exponent. Hey, Church. Well,
Alright, let's take a look at these real quick here. Okay, so for B, as x goes to negative infinity, f of x would go to, this is a positive even degree. It'll look like this. So my y value is going to go to positive infinity. And as x goes to positive infinity, f of x will also go to positive infinity. Okay, so talk about C and D here. Okay, so again, we don't need to multiply these out. All I care about are the degree of the leading term and the sign of the leading term. So if I were to multiply all this out, okay, I've got a squared on this and a first power over here. Okay, my total degree of my highest term is going to be 3, right? It's going to be positive because my x's everywhere are positive. So I'm looking at a positive third degree. Okay, so as x goes to negative infinity, f of x will go to negative infinity. And as x goes to positive infinity, f of x will also go to positive infinity. The final one, okay, I've got a third, the first degree. So this will end up being a fourth degree polynomial. And my leading term will end up being negative because I have a negative x times this x cubed over here. So a negative fourth degree, the end behaviors will both be going down. So we can say as x goes to negative infinity, f of x goes to negative infinity, and as x goes to positive infinity, f of x goes to positive infinity. Okay.
That's a negative fourth power. Shouldn't those both be going the same way?
Oh, shoot. Sorry. Yeah, I said that.
This
Your